Hello and welcome to Honors Function. In this introductory video, I will cover some of the qualities and skills that will be required of you in order to be successful in this course. First, you really need to enjoy math. You need to be curious about it. If you ever ask the question in class, why do I need to learn this? Maybe that's not the right class for you. The course is taught at an honors level. Therefore, regularly, you will be facing some problems you have not seen in class. You are expected to spend time trying to solve it. Maybe you won't be able to solve it, and that's okay. What really matters is that you try. How long are you going to ask? Well, it all depends. 5 minutes is surely not enough. 10, 15 minutes, that's on the short side if the problem is challenging. You have to try something. It's not about what you've learned in class, it's how you think, okay? Second, just like in any other courses, you have to work regularly and diligently. This is a flipped classroom. Every night you will be required to watch a video that will last around 20 minutes, sometimes shorter, sometimes a little bit longer. Before the video you have to print my notes and you will follow along, especially when I cover some examples. You are required to do all the examples in the notes, okay? That is what constitutes your homework. Third, you have to have a sound background in math. You need to recall accurately, with little or no review, the algebra skills you have learned in prior courses. Particularly, you need to be able to handle fraction, expression involving fractions. You have to be able to expand and factor variable expressions. Let's do some problem assessing these techniques. I will start with example number 1. Here's an expression that involves some negative exponent, quite a lot, right? Every exponent is a negative exponent. And some fraction. The fraction is actually the same everywhere. It's negative 3/2. So how are we to find the value of this expression? Okay, evaluate means find a value and not an expression. How are we going to do this? All right. Well, my first instinct is to deal with these negative exponents. Please make sure you don't distribute this. You don't do that. This is a sum that you have inside, okay? An exponent does not distribute over a sum, okay? So I hope you remember that. This is a pretty important one. All right, so let's deal with the exponent that we have inside the parentheses, all right? The rule is that if you have a over b to the negative n, this is the same as b over a to the n, and that's where I will start. So this expression is equal to negative 2/3 to the cube plus negative 2/3 to the square plus negative 2/3 to the first power. And I still have a negative power outside. Now that I have positive power inside, I can remove them. What is negative 2/3 cubed? It is negative 8 over 27. 2 cubed is 8, 3 cubed is 27, and the negative stays because you have a cubed. Negative 2/3 square now. This negative will not stay because you have a square, right? So it is plus 2 square is 4. 3 square is 9, plus 4, 9. And finally, the first power, well, you can just remove it without doing anything, minus 2/3. So here is a sum of, don't forget the negative exponent right here. Here's a sum of 3 terms. Let's get the common denominator. The common denominator, of course, is 27. So here you need to multiply 9 by 3 and 3 by 9. Right here. Therefore, what do we have? We have negative 8 plus 12 minus 18 over 27 to the negative 1. So what is negative 8 plus 12 is plus 4. Plus 4 minus 18 is negative 14. Negative 14 over 27. 14 is made of 2 and 7. 27 is only made of 3's. So you cannot simplify this fraction, okay? And therefore the answer is negative 27. You just flip it, right? Negative 27 over 14. This negative 1 just tells you to flip the fraction. That's all. All right. You do number 2. I will do number 3. Number 3. This is an expression containing some fractions. How are we to simplify this? Well, we have to write it as a over b and not have some fraction here or fraction there. Just a over b, simply like that, okay? So how am I going to do that? Well, let me rewrite it. I'm going to show you what I like to do in this case. 5 over 2x, so here the denominator is 2x, over 6 over x squared plus 2 over 3x. So what I like to do in this case is get rid of all my denominators at once. How do I do that? I multiply both sides of the main fraction by a quantity that will eliminate all the denominator. This is going to be the lowest common multiple of the denominators. So I need a 2 to eliminate these 2 right here. I need a 3 to eliminate the 3 right here. And I need an x squared to eliminate this x. Of course, these 2 x's will be eliminated with this x squared right here, okay? So I'm going to multiply both sides by 6x squared. What do I have? Well, 2x will go with this 2 and this x, so we're left with 5 times 3x, 15x, over here, this you have to distribute it over this and over this, right? So the x squares will go, and you're left with 6 times 6, 36, plus, and here you have 2 over 3x times 6x squared. So the 3 and the 3 will go. Now remember, this x is still there, right? The 3 and the 3 will go, and this x will go with one of them. And so you multiply 2 by 2x plus 4x. That's it. Pretty straightforward. Basically, one step. Please do example number 2 and example number 4. Let me continue with the next set of examples. So, the factorization. This is a technique that is very important in math, and it is ubiquitous. It shows everywhere. Let's factor the first expression. Look at the number 5, 17, 14. There are no common factors to these numbers. So now what do we have? We have y cubed, y squared, and y. Well, let me start by taking a y out, okay? So it's 5y squared plus 17y plus 14. Okay, now I'm going to try to factor this. Maybe I will, maybe I won't. Maybe it will factor, maybe it won't factor. How do I do it? I'm going to set 2 sets of parentheses and see if I can multiply linear terms in each. So for the 5x squared, I will have a 5y and a y right here. This is how I get my 5x squared. 14, well, 14 could be 1 and 14, or 14 and 1, or it could be 2 and 7, or 7 and 2. So you see, you have a lot of options here. You want 17 in the middle, okay? So my first instinct is not to try 1 and 14. And maybe I'm wrong there, but I don't want to try 1 and 14. So I'm going to try 7 and 2. Now, I'm not going to put 7 here because I'm going to get up to 35, and then I have to go down to 17 when I add, so I don't think that's going to work very well. So I'm going to try 7 here and 2 there. All right, now let me look at the sign. It's plus and plus. So I'm going to put a plus and a plus. Here's my 14. Now let's look at the middle term. You got 7 and 10, and that's 17, and all the sign works. I got it. Here we go. Please do number 6 and number 7. Okay, next set of examples. Solve the equations. So look at number 8 and number 9, please. These are the same equations, right? But in number 8, I want you to solve it for x, while in number 9, I want you to solve it for y, okay? So let's look closer here. What do we call this kind of equation in x? Well, you have an x squared and an x. This is a quadratic equation in x. What do we call the second kind of equation for y? Well, you have a y right here and a y right there. There's no y squared. This is a linear equation in y, okay? So the same expression can be a quadratic expression in one of the variable, x, or it can be a linear expression in another variable, y. I'm going to do number 8. You have to solve for x. It's a quadratic expression. You can use a quadratic formula. So x equals, so you remember the quadratic formula, I hope, negative b plus or minus square root of b squared minus 4ac over 2a, right? So it is negative b is negative 2, so it is 2 plus or minus b squared minus 4ac, so it's 4 minus 4 times, what is a? Well, a is a coefficient of x squared, that's y. 4y. And what is c? c is negative y. So it is, here we go, 4 times y times negative y over 2a over 2y. Okay? So what do we have? I'm going to write this way. So we have 2 plus or minus. So what's under the radical? We call that the radicand, right? So it is 4 plus 4y squared over 2y. Okay, well, we can go further here. We have to simplify the radical, right? So it is 2 plus or minus, take a 4 out, factor 4, that's 1 plus y squared over 2y. A little bit further now, the 4 will come out of the root as a 2, and we have 2 plus or minus 2 square root of 1 plus y squared over 2y. And finally, we can simplify everything by 2, so it is 1 plus or minus 1 plus y squared over y. And you can't go further, okay? So now you do number 2. Now number 2 is going to be easier because it is linear in y, right? So it should be pretty easy. Next, I'm going to do number 11, and I'm going to let you do number 10. So number 11, you have to solve for x squared. It's at the denominator. The first thing I will do is flip both sides of this equation, okay? Remember, if you have a equals b equals x over y, then you can flip both sides of this equation and write b over a equals y over x. Of course, assuming that a and x are not 0, okay? So let's do that. So we have x squared minus 1 over 1, so I'm not going to write it, equals 1 over pi. Then we have x squared equals, I'm going to move the 1 plus 1 over pi. Okay, well, this is a square. This is a quantity that is positive, so I can go further and write that x is plus or minus square root of 1 plus 1 over pi, okay? And this expression is completely fine. Here's another quality that you will need to be successful in this course. I'm going to be focusing on terminology and notation, okay? And you have to pay attention. Math is a very clear and precise language, and you have to read carefully any statement. Okay, let me show you what I mean by that. Example number 12. Write a variable expression that represents the square of a sum and another one that represents the sum of squares. Okay, and then are both expressions equal? Okay, so the square of a sum. So first you take a sum, a plus b, and then you square it. Here we go. The other one is a sum of squares. So first you take two squares, a squared and b squared, and then you take the sum of them, all right? And I hope you remember that these two are not equal, all right? Now, your turn with 13. Let's go with another very important skill this year. You have to think. Okay, you have to think. You cannot ask the question, show me what to do. This is not an honor level question. You will have to put things together. Okay, and for that you will need to show some grit and determination. It's not going to be given to you. You're going to have to dig. Let me show you what I mean with the next example. Assume that x and y are two positive numbers such that x is above y. In each problem, I will call the ratio of the two numbers the ratio of the larger one to the smaller one. Okay, what did I just read right here? In each problem, so I'm referring to these problems here, 14, 14, I don't know how many there are, right? I will call the ratio of the two numbers. So I'm defining what I call the ratio of the two numbers. It's going to be the ratio of the larger to the smaller. Therefore, x is larger. So what I call the ratio of the two numbers is x over y. Okay? In each problem, you will find the value of that ratio. So here, I'm guessing I should come up with x over y equals, and here I need a value. Okay? I think I grasped my problem. All right. The ratio of two numbers is the same as the ratio of their sum to the larger number. So the ratio of two numbers, we said that's x over y, right? Is the same, so that's equal, as the ratio of their sum to the larger number. So x plus y over, what's a larger one? Over x. Okay? And what do you have to find? You have to find the value of x over y. Oh, so I need to find this value right here. But be careful. X over y is not only here, but it's somewhere there too, right? There's an awful lot of x and y there. How are we going to do that? Any idea? You can pause the video and try on your own, okay? Here's what I see right here. This is a sum, and I have like x over x and y over x. Now, y over x and x over y, these two are related, right? So here's what I'm going to do. I'm going to say that this is the same as 1 plus y over x. I hope it's clear to everyone. I just did x over x plus y over x. That's the definition of the sum of two fractions, right? Okay, and now what do I have? I have that ratio, okay? So let me rewrite the whole thing right here. I have x over y equals 1 plus, and here I don't want y over x, I want x over y. So what am I going to do? I'm going to do 1 over x over y, right? Because 1 over x over y is y over x. Okay, let's make our life easy. Let's just call that r. And so my equation is r equals 1 plus 1 over r. And I want the value for r. Okay, so now that should be a pretty okay problem for everyone, I hope. You multiply both sides by r. So you have r squared equals r plus 1. And so you have r squared minus r minus 1 equals 0. This is a quadratic equation in r. So let's use a quadratic formula. R equals negative b plus or minus b squared, 1, minus 4ac. So a is positive, c is negative, so that's going to be a plus. 4ac, 4 times 1 plus 4 over 2. Okay, 2a, that's 2 times 1, 2. So we have r was x over y, so x over y equals 1 plus or minus root 5 over 2. Now, please, don't think you're done here. You're not done. You got two possibilities, right? You got 1 plus root 5 over 2, and you have 1 minus root 5 over 2. Are these both okay? Well, you have to think. Let's go back to the problem. What is x and what is y? Well, x and y are both positive numbers, right? Positive numbers. It's written right here. Therefore, if they're both positive numbers, you're not going to be able to take the ratio and find something negative. I hope you all know that root 5 is above 1, right? So this is negative. So you got to discard this one, and the solution is 1 plus root 5. Okay, your turn with the next and last example. Finally, I strongly encourage you to meet with your teacher whenever you need to. You shouldn't really meet with me regularly. This is not something we should see at the honor level, but here and there to address some misunderstanding, or if you're stuck somewhere, you should meet with me. Please make sure to read the advice given that prior students who have taken this course, when they were asked, what would you tell other students if they ask you how to succeed in this course? There's some interesting answer. This is just a sample. Please make sure you read this. Also, before you come to class, print class assignment number 0. It's all posted on Haiku. Thank you for watching.